Hey everybody, you made it. We're going to be doing our first flipped classroom video today, working on notes on linear expressions, slope-intercept form, standard form, and point slope form. So let's go ahead and go back to something that you already know. Let's see what you remember. So remember that linear, the root word is line, and that's because a linear function or equation always describes a line, just like its root word. Remember that lines can be up and to the right, down and to the left. They could be horizontal, and they can be vertical. So keep in mind, anything that I write, you want to go ahead and add in, use color, however you'd like to, so that your brain can learn it. So when we're talking about linear functions, linear equations, properties of a line, there's two parts to a line. One is the slope. Another way to call the slope is the rise over the run. Okay. We can also call this the change in the y over the change in the x. And so the slope tells you the direction or the steepness of where the slope is going or where the line is going. And the starting point, you always want to start with the starting point, and then you can use the direction. In general, we use the y-intercept. Okay, and the y-intercept is where it crosses the y-axis. Now remember, the y-axis is the vertical axis going up and down, so wherever the line hits the y-axis, so let's say, for example, we're using this pink line, this point right here is called the y-intercept. Also, it's where the x value is 0. So if you remember, slope is two words. Remember, we just said it, the rise over the run, the change in the y over the change in the x. So if you've got two different points on a line, 1, 2, this is the first point, this is the second point. We call this, every point has two components, an x, comma, y, where the x value is where it would line up on the x-axis, and the y value is where it would line up on the y-axis. So we call this x1, y1, because this is the first point. So x sub 1 means x of the first point, y sub 1 means the y of the first point. This here is x2 because it's the second point, so this is x of the second point and y of the second point. So when we take our formula, we plug those numbers into this formula right here. Slope is the value of y2 minus y1, so we take the y of the first point, and then we take the x of the second point, x2, minus x1. And then the value that we would simplify there would give you the steepness or the direction of the slope. Okay, so let's talk about that. Let's find the slope here. So we see that there's a line. There's 2 points that they give us on the line. We're always going to write down those points as an ordered pair, x comma y, and this is x1 comma y1, x2 comma y2. Again, the 1 and the 2 just mean it comes from the first point or the second point. And now because we're looking for the slope or the steepness of it, I'm going to plug it into the slope formula, which is y2 minus y1 over x2 minus x1. So y2 is 6, y1 is 2, x2 is 2, x1 is negative 4. Keep in mind that negative comes after the minus in the formula, so you want to keep it separate. Whenever there's a negative coordinate, I always put a parentheses around it so my brain doesn't get mixed up. So let's go ahead and do the top. Here we go. 6 minus 2 is 4 on the top. And then 2 minus negative 4. Remember, minus and negative we can change to add the opposite. 2 plus 4 is 6. That's 4 over 6. We can reduce it. 4 divided by 2 is 2. 6 divided by 2 is 3. So our slope is 2/3. 2/3, and notice that's a positive slope, which means it goes up and to the right. So what if they didn't give you a graph? What if they just told you the 2 points that we'd be using? Well, if they list it, you can still say, well, this is the first point listed. We're going to call that x1, y1. Here's x2, y2. You could plot these out and connect the dots and get your graph, but you don't need it to find the slope. We know the slope is, type in your formula, y2 minus y1, x2 minus x1. And now we're going to plug those in. Here's y2 minus, no, I'm going to kind of, before I do that, let me show you how I do this. I usually set up the bar with the minuses in the middle so I don't forget. And then I come through and I assign y2 is -1, y1 is 5. x2 right here is 6, and x1 right here is 3. So now when I simplify this, we go across the top. 1 minus 5 is really like saying plus a -5. So this is -6 divided by 6 minus 3 is 3. We can reduce that. 6 divided by 3 is 2, so this is a -2. So that slope is a -2, which is going to go down and to the right. Remember, the slope of the number of the slope will tell you how steep it is, but also which direction that it's going. So if a slope looks like this, where it's going up and to the right, we call this a positive slope. If the slope is going down to the right like this, we call that negative slope. If the slope is going completely perfectly horizontal, that's 0 slope. And if the slope was going perfectly straight up and down, that's a vertical line, but there's no way to put a value on that, so we call that undefined. If you were to calculate that out, you'd get a 0 in the denominator. One way that I like to think about this is with a roller coaster. We've got positive and negative slopes that tells you when you're going up the roller coaster and down the roller coaster. But if you're on a roller coaster that stays flat like this, that is 0 fun, right? And if you're on a roller coaster that goes straight down like this, that is so much fun. It's undefined, right? So that's one of the ways you can remember how to talk about slope. So let's remind ourselves of forms of linear equations. One form is called the slope-intercept form, and that's because there's 2 pieces of information that are readily available to us in this form. One is the slope, and the other one is not just any intercept, but it's specifically the y-intercept is ready to go. And if you remember from way back when we learned, the letter that we use to stand for slope is called m, and the letter that we use for the y-intercept we call b. So slope-intercept form is y equals mx plus b, where m is just whatever slope we have here inserted in, and b is the value of the y-intercept. So x and y will stay x and y, but you'll see a number instead of the slope, and you'll see a number instead of the y-intercept. Okay, next one. So when we're talking about point slope form, that's because the information readily available is a point. Remember, a point has 2 components, an x component, so x1, and a y component for the point. And then a slope, again, is also the letter m. So when we're talking about this form, it has x and y in the form. But instead of just x and y, we also have, okay, so we say y, the minus is part of the form after the x and the y. And then we say it's y minus y1, which is the y coordinate from the point, and x minus x1. We put our parentheses around the x and we put the m in front. So the m is still slope right here. So this is our point slope form. We say y minus y1, which is the y value of the point, times equals m, which is the slope, times x minus the x value of the point. And last but not least is standard form. And the way we kind of remember standard form is just like when you were in preschool or kindergarten, what was standard that you learned there? You learned your A, B, C's. So to learn standard form, we say it's A x plus B y equals C, where A, B, and C are numbers or integers, okay? There's a rule about A. It has to be a positive whole integer. And then C, we call that a constant, which means it's just a number by itself. It's not attached to any variables. And then A and B, the other way that we can call this is these are both coefficients, which a coefficient, remember, is just a number being multiplied in front of a letter. So we call these the coefficients. So if I say a coefficient of x, it's the number in front of the x. A coefficient of a term is the number in front of the term. All right, that's all for today. I'll see you back in class tomorrow. Good job.